Hi everyone, my name is Kshitij and on this channel we talk about robotics, research and academia. In today's lecture, we are kicking off a new lecture series in the TT100 lecture series called TT102, Introduction to Python for Robotics. This is the lecture 1 of the lecture series, which is going to be the course introduction and overview. So if you're new here, I'd like to quickly introduce myself as well, and we're going to go over what is Python, why Python for robotics, what are the objectives and the target audience for this course, prerequisites in any, and the teaching methodology and anticipated outcomes for this lecture series. So as I said, my name is Kshitij. I'm a robotics educator and consultant. I have a bachelor's in engineering from the Hong Kong University, master's of science from the University of Edinburgh, and a PhD in robotics from JAIST in Japan. I've mentored more than 5 or 6 dozen students around the world, and I have nearly 15 years of experience in research and teaching in robotics. I've built custom robots, I work with commercial robots, and I develop algorithms and deploy on both of them. And I come from a background in field robotics, which means I develop the code, I deploy it on the robot, and I test them out in the field. So what is Python and why are we interested in learning it? So Python is an interpreted programming language that was created by Guido van Rossum from early 1990s. It's known for its readability, simplicity, and versatility. It has a large and active community of developers and has a rich ecosystem of libraries and frameworks. And why do we want to learn Python for robotics? The reason being it is a general purpose language, which means it has versatile applications. The syntax is easy and beginner friendly. As I said, there's rich support from the community, allows rapid prototyping, can integrate with other languages as well. So for instance, if you're building a project that involves other libraries or other source codes from C or C++, for instance, you can easily integrate Python together in the entire ecosystem. And this works especially well if you're using the robot operating system, which is ROS for short. And this is something that we're going to look into in this course as well. And briefly, I have touched upon it in one of my lectures in the TT101 lecture series, which was an introduction to robotics, mobile robotics for absolute beginners. And there's abundance of education material and resources for Python. My lecture series being one of them. There are other content creators and course creators that have built numerous resources for learning Python for beginners and even advanced level users. But the focus of my scope would be in the context of Python, specifically for building and deploying robots in simulation. And then in some other future advanced course, we will also look into simulation to real world transfer. But for now, we're focusing on simulations. The objectives of the course are to develop an understanding of Python fundamentals and to apply them to robotics examples. As I said, for this, we're going to use the robot operating system for integrating our source code with the simulated environments and test them out on robots in simulation. And we're going to implement numerous control algorithms, path planning algorithms, obstacle avoidance, and so on and so forth, and enhance our object-oriented coding abilities and prepare for advanced robotic studies. The target audience for this kind of course are typically robotics enthusiasts and absolute beginners who want to learn various facets of robotics, as robotics is an interdisciplinary field. Python developers who are already having some exposure to Python but want to learn Python specifically in the context of mobile robotics. Every time I say robotics in this lecture series, I mean primarily mobile robots. We are not going to look into manipulators, as I've already started narrowing down the scope in the TT101 lecture series. And the robot developers who are kind of experienced with building robots, such as electronics engineers or mechanicals or mechatronics engineers, but they want to get into coding for robotics. So this course is ideal for these kind of audiences. And this is going to be a standalone course, which means I'm going to develop as much depth as I can in terms of learning Python primarily for mobile robots, but there is no prerequisite for coming into this kind of course. But if you have some prior exposure to coding, for instance, in any other object-oriented language, that would be completely fine and actually very useful. If not, we're going to go step by step in this course anyway. So my teaching methodology has always been self-paced and on-demand learning, especially with my YouTube lecture series, and there's no pressure for grades or assignments as in the conventional teaching ecosystem. You come here to learn only. You're not doing it for any grades or assignments or to pass a course or for any other strings. There's no strings attached, right? So it's a self-paced learning, which means you can stop and pause the video as many times as you want, take as many breaks as you need. And it's on demand, which means you are coming to find this video and you're landing on this video when you're actually ready to learn it. It has hands-on Python programming exercises and hands-on robotics assignments, but then again, those are voluntary assignments. You do them as you please. My goal and objective is to give you some teasers and show the end case when the code actually works, how it is supposed to work like. But it's your job to fill in the blanks in the code that I leave and then make it actually work. And I would encourage active discussions and comments in our Discord server as well. You can find the comment sections in the video below and in all my lecture series anyway. So there's typical YouTube comments. And then there's also a dedicated Discord server that I've built where you can hang around with your friends and fellow learners and have active discussions. You can find the link for that again in the description and also in the channel description. The anticipated outcome for this kind of course are to make you proficient in understanding Python programming, especially for robotics. So broad spectrum Python, of course, because you're going to use most of the fundamental concepts of Python anyway, but more prominently, I'm interested in getting you up and running with robotics and the ability to develop and implement Python-based robotics applications. So you're going to learn problem solving, coding, debugging skills in the context of projects and in robotics, and you're going to get hands-on exposure. And it's going to build a strong foundation for further studies, and especially if you want to go into research, for example, a PhD in robotics. So this is primarily meant for those kind of preparing for those kind of career objectives. And there's going to be numerous robotics algorithms that I'll cover in the TT100 lecture series, which is meant for undergraduate or bachelor level students, and TT200 lecture series, which is more for master's or early stage PhD level students. So you can, in those lectures, I normally give pseudocode. So you can borrow those algorithms, use this ecosystem we are going to develop in this lecture series and start implementing them and seeing them in action on your own. Thank you so much for listening, and see you again the next time. Until then, be sure to like, share, and subscribe. And in the next lecture onwards, we're going to start going deeper and deeper into learning Python for robotics.